Welcome to Metrology lecture series. In the present video, we will discuss the evolution of surface finish. Surface finish can be measured using the numerical values. These values are calculated by comparing the surface with a reference line called as a datum line. In general, surface roughness is evaluated using the following three methods. First one is the peak to valley height method. Second one is the average roughness method. Third one is the form factor or bearing curve method. In peak to valley height method, measures the vertical distance between the highest peak and the lowest valley on the surface. In the average roughness method, calculated the average of all the small surface irregularities over a given length. And in the form factor or bearing curve method, studies the how much of the surface will actually support a load by analyzing the surface profile. First, we will discuss the peak to valley height method. This method measures the maximum depth of surface irregularities within a given sample length. So the largest depth value is taken as the measure of surface roughness. So here we have to consider the maximum depth of the surface irregularities. So here we have to consider the largest depth value. So let's consider among these three values, this is the largest value, and this largest depth we have to consider as the surface roughness. But in this method, it is having the one of the drawback. When the two different surfaces may have the same maximum height but completely different surface textures, so in such cases the value is obtained does not truly represent the actual condition of the surface. So in this method, if we got the Hmax value, so maximum largest depth value is the same for the two surface textures, but texture profile is completely different, but Hmax value is the same value. So in such cases, the represented value is not a true condition of the surface roughness. So this method may not always give an accurate or complete assessment of the surface roughness. So to overcome this limitation of this method, an improved peak to valley height method is defined. So in this method, we have to draw the lines parallelly to the general lay of the surface. In the schematic, you have to observe, here you have to draw two parallel lines, which is the parallel to the direction of the lay, so direction of the surface pattern. So next we have to adjust these two lines. First we have to adjust the upper line. So upper line is positioned so that the only 5% of the total trace length is lies above it. So I have to adjust this line. So how we are adjusting mean? So in this upper line, so only it should be have the 5% of the total trace length. So this length should be the only 5% of the total length. Let's consider the total trace length is capital L. So here total length of this upper line is 5% of the total trace length. Similarly, have to adjust the lower line. So lower line is positioned so that the 10% of the total trace length lies below it. So here it should be the only the 10% of the total trace length. We have to adjust these two lines. So upper line we have to adjust. It should be have the only 5% of the total trace length, and the lower line it should be the have the 10% of the total trace length. Then the vertical distance between the these two lines is taken as the improved PV value. So here H is represents the peak to valley height. So this vertical distance small h is taken as the PV value. So here H value is the peak to valley height value. This method gives a more realistic measurement of the surface roughness because it reduces the effect of extreme peaks and the values. So however, you have to refer this diagram. So this concept is represented. So I have to refer this diagram. So here it is representing the procedure of the peak to valley height method. Next we will discuss the average roughness method. In the average roughness method, assessment of average roughness is following the three statistical criteria. So first one is the CLA method or the centerline average method. In this method, average of the absolute heights of all surface points are measured from the mean line. And then this average value we are representing as the RA, R suffix A. RA value is the most commonly used method to measure the surface roughness. So in the CLA method, average of the distances from all surface points from the mean line without considering whether they are the above or below the line. So let's consider this is the center line, center mean line. With reference to this line, so we have to measure these heights. So let's consider these are all the values H1, H2, H3 up to the Hn. So let's consider up to the Hn. So H1, H2, H3 like that. So after that one we have to considering the average value of these absolute values. So here we have to consider the only positive values. It should be the above the line or maybe the below the line. We have to consider the only positive H values. Then RA value will become the average height of the all these heights. Then RA equal to the H1 plus H2 plus H3 up to the Hn divided by n. So in the CLA method, centerline average is defined as the average values of the ordinates from the mean line regardless of the arithmetic sign of the coordinates. So have to considering not only the height in this method, so have to considering the average areas also. So let's consider, so this is the A1 and this is the A2 and this is the A3 and this is the A4 and this is the A5. So now I have to considering the average value. So absolute average areas also have to consider. Then RA will become the A1 plus A2 plus A3 up to the AN divided by capital L. So RA equal to the summation of these all the averages divided by capital L. Next method in the average roughness method is the RMS method, that is the root mean square method. The square root of the average of the squares of the surface heights measured from the mean line. So in the simple words we have to discuss it for the RMS method. First we have to draw a mean line of the surface profile. So which is observed in the schematic representation. First we have to draw a mean line of the surface profile. Then we have to measure the heights of the surfaces from this mean line at equal intervals. Let's consider H1, H2, H3 up to the Hn. So I have to measure the heights of the surface from this mean line. Next, we have to square each height. Then it will become the H1 square, H2 square, H3 square up to the Hn square. After that, we have to find the average of these squared values. Then we have to take the square root of that average. So here, height of the RMS value. So H RMS. it will become the square root of h1 square plus h2 square plus h3 square up to the hn square divided by L. So this is the RMS method. Next we will discuss the another method in the average roughness method, that is the 10-point height average value. In this method, the average difference between the 5 highest peaks and 5 lowest values of surface texture within the sample length. So this is representing by the RZ. So RZ will become the 10-point height of irregularities. What are the 10 points mean? So 5 highest peaks and 5 lowest values. Then you have to consider the difference. Then you have to take the average. Then RZ will become the, so here 5 highest peaks and the 5 lowest values. So then average it will become the 5 only. Then RZ equal to the 1 by 5 R1 plus R2 plus R3 plus R4 plus R5. So here R1, R2, R3, R4, R5 are the 5 highest peaks minus R6 plus R7 plus R8 plus R9 plus R10. So here R6 to R10 are the lowest values. So then you have to considering the difference. So R1 plus R2 plus R3 plus R4 plus R5 minus R6 plus R7 plus R8 plus R9 plus R10, and have to take in the average. So then here 5 values differences, then so 1 by 5. So RZ equal to the 1 by 5 into R1 plus R2 plus R3 plus R4 plus R5 minus R6 plus R7 plus R8 plus R9 plus R10. And one more thing in this method, so measured from a line parallel to the mean line and not crossing the profile is used to denote the amount of surface roughness. So here we have to draw a line. So it should be the parallel to the mean line, but you should not to cross the profile. So always have to draw the, so below of the these irregularities. So this is the 10-point height average value method. So this method is a simple way to measure the surface roughness. It measures the total height of surface irregularities within the given sample length. But however, this method having the few limitations. So one is the, it does not consider how frequently the irregularities are occur, and it does not considering the shape of the surface profile. So these are the limitations of this RZ method. Next we will discuss the form factor or bearing curve method. So form factor and bearing curve methods are the some special characters are used to evaluate the surface texture. So form factor tells us how much of the surface is actually carries the load. So let's see how to calculate this form factor. First we have to draw a baseline of the surface profile. So let's consider. So this is the baseline for this surface profile. Then I have to measure the area of the material above this baseline. So next I have to measure this area above this baseline. Next I have to draw a rectangle with respect to this baseline. We have to draw a rectangle. So which is the completely covers the profile. So here completely covers the profile of a given sample length. So after that, form factor is defined as the area of the material above the baseline divided by area of enveloping the rectangle. So first I have to draw a baseline and we have to measure the area above this baseline. Surface irregularities area we have to consider it. Then we have to draw one rectangle, so which is the cover the complete this surface profile. Then our two form factor is defined as the area of the surface irregularities divided by the area of the rectangle. So form factor equal to the area of material above the baseline divided by area of enveloping the rectangle. Next we will discuss the bearing area curve. The bearing area curve is also known as the Abbott's bearing curve. Bearing curve is obtained by adding the length of the material portions at different depth measured below a reference line. So in the schematic you have to see this one. Let's consider capital L is the total sample length and A, B, C are the material portions and X, Y, Z are the different depth which are the measured below a reference line. So then this curve shows the percentage of bearing area available at the top surface gradually wear out. So here we have to adding this length. So this A, B, C. So it will become the A plus B plus C. Then this curve. So this curve shows the percentage of bearing available at the top surface gradually wear out. So figure shows the how the bearing area curve is determined. So next we have to discuss the bar chart. So which is representing the RA values for the various manufacturing process. So we know that when the lapping and grinding process are the surface finishing process, here RA values are the very less values, and we know the laser machining process we obtain the good surface finish. So here also RA value is less, and reaming also having the reaming surfaces all will get the good surface finish. Similarly in the milling also we will get the good surface finish and milling and drilling. And next one is the sawing and cutting, flame cutting, and the casting and forging which are available is the poor surface roughness. Next we will discuss the conventional method for designing surface finish. So according to IS 696, surface texture is specified by showing the following main characteristics using the standard symbol. So this is the standard symbol of the surface roughness. So here, various characteristics are represent within the symbol. So that is the first one is the surface roughness, RA value in the micrometers. So here just this one above the triangle we are representing the surface roughness. Next one is the machining allowance. So machining allowance in millimeters. So here in the symbol have to see, here we are representing the just side of this triangle we are representing the machining allowance. So this is the 1.2 will become the machining allowance. Next third one is the sampling length. So here just below this square root symbol we are representing the sample length. So here 2.5 will become the sample length. Next one is the machining or production method. Just above this square root symbol we are representing the machining method. So here milling is the machining method. Next one is the direction lay. So symbols, lay symbols we are representing the within this square root at the bottom of this square root we are representing. So here, this is the lay symbol. So this is the regarding to the evolution and representation of the surface roughness. And thank you.